Namaskar and welcome back to Aviation Avi, go where you feel the most alive. Have you ever wondered how the air traffic control controls so many flights in the sky? How the meteorological departments predict storms coming in the future? It is with the help of the equipment called radar, that stands for radio detection and ranging. It acts like eyes which can see through the clouds and even the dark. So with this video on radars, we will be understanding in part 1 of the video what is radar, how it functions, what are its types and its real-time application. In part 2 of the video, we will be understanding and learning about the different types of radars used at an airport, what are the safety measures to be adopted while using these radars and what are the actual application of this radar. So without any delay, let's get started with part 1 of the video. To start with, what is radar? Radar stands for radio detection and ranging. It is a system that uses radio waves to determine the distance, that means ranging, direction, which means azimuth and elevation angles, and radial velocity of object relative to the site. It is a radio determination method used to detect and track aircraft, ships, spacecraft, guided missiles, motor vehicles, maps, weather formations, and terrain. So, radar is used to track various objects, give its directions, its velocity, its azimuth, its elevation angles, so that the person tracking that object is able to identify the location, the speed of the object precisely. Let us look at the components of radar. The radar consists of a transmitter which transmits electromagnetic waves, which passes the duplexer and then goes to the antenna which emits these electromagnetic waves. These waves, after being hit from the object, are reflected back, forming echoes which pass through the antenna, then to the duplexer and goes to the receiver, where these electromagnetic waves are processed and as an output you see display on your radar screens. This helps you identify the location and speed of object in question. Now that we know the components of radar, let's see how it functions. A magnetron or the power supply generates high frequency radio waves. The duplexer switches the magnetron through the antenna, and the antenna acts as a transmitter, sending a narrow beam of radio waves through the air. These radio waves hit the target and are reflected back, forming echo. By analyzing the time it takes for the waves to return, radar determines the distance and speed of the object. We know from our junior classes that distance is equal to speed into time, and here the waves travel twice from the transmitter to the object and back from the object to the receiver. So the waves travel the same distance twice. So keeping this in mind, we have the equation as distance is equal to speed into time upon 2. Since the wave has traveled the same distance twice, we are including this division by 2 in the equation. So dividing the multiplication of speed into time by 2 gives us the distance the object is from the receiver or the transmitter. There are two types of radar, the primary radar and the secondary radar. The primary radar consists of three components: the transmitter, the receiver and the display unit. Here we will see that for getting data or for getting information from primary radar, there is no active involvement of the object. In this case, the electromagnetic waves are emitted from the transmitter, which, when hit the object, they are reflected back, and then a portion of this reflected energy is received by the receiver. This is then fed into the display block. In the display block, the processor compares the received signal and that of the reference signal and does some calculations to give the appropriate range and bearing of the particular object. So here we see that the object does not have any specific involvement in the process. It only reflects the energy that is being sent by it. So this is the concept of primary radar. Unlike the primary radar, the role of the object is very much active in case of secondary radar. Here in the secondary radar, there are two components: the ground-based interrogator, or the one that sends signals towards the object, and the airborne transponder, which is present inside the object. The transmitter in the ground-based interrogator sends signal which is received by the airborne transponder in the object. After interpreting the received signals, the transmitter in the object sends back signals to the receiver, which is received by the ground-based interrogator. Based on the interpretation of these sent and received signals, the exact information required by the ground-based interrogator is extracted. So in this case, we see that the role of the object is very much active. Now, due to the increase in traffic density and inherent deficiencies in the primary radar, nowadays the primary radar are slowly being replaced by the secondary radar. By now, we are clear with what is radar, what are its components, how it functions, and what are its types. Let us look at the application of radar. The air traffic control in aviation uses radar to safely control the air traffic en route and in the vicinity of the airport. The radar is used to control aircrafts on ground and also control vehicular traffic at major airports by means of high-resolution radar. By means of this radar, the air traffic controller can see the position of their aircraft, and also in different kinds of display they can see the position of the vehicle, the aircraft on ground, and have strict monitoring over them in order to ensure safety compliance and prevent any accident or incident. Further, radar has been used with the GCA, that is Ground Control Approaches System, to guide the aircraft to a safer landing even in case of bad weather. The second use of radar is in aircraft navigation. The weather avoidance radar that is installed at the nose of the aircraft is used to outline the regions of precipitation to the pilot. Like you can see, when you lift the radome of the aircraft, you can see the weather radar present here, which sends and receives signals to alert the pilot of areas of heightened caution which may cause turbulence to the aircraft. So based on this information given by the weather radar inside the radome of the aircraft, the pilot navigates its path. Radar is also used for terrain avoidance and terrain following. Although it may not always be thought of as a radar, radio altimeter is also a form of radar. Ground mapping radars of moderately high resolutions are used extensively these days. Next application of radar is for maritime navigation. Radar is used for enhancing the safety of ship travel by warning potential collision with other ships and detecting navigation buoys, especially in poor visibility. Shore-based radars of moderately high resolution are also used for surveillance of harbors as an aid for navigation. Radars also have military applications. Many of the civilian applications of radar are also employed by the military. The traditional uses of the radar for military application, however, they have been used to identify enemy aircraft and to control and guide anti-aircraft guns and surface-to-air missiles. The next application of radar is for meteorological uses. The radar is also used by the meteorological department to detect approaching storms and issue timely forecasts and warnings to prevent loss of life and property. There are space applications of radar where space vehicles use radar for rendezvous and docking. They use these radars to ensure docking of spacecraft to a particular location, guiding the spacecraft to a particular location and help in appropriate docking. Some of the largest ground-based radars are used for the detection and tracking of satellites. Satellite-borne radars have also been used for remote sensing and earth resources, which include the mapping of sea conditions, water resources, ice covers, agriculture and forest conditions, geographical formations and environmental pollution. Furthermore, with the advancement of technology, there are vehicular applications of radar where modern vehicles today are equipped with radar and which helps them avoid collisions and monitor traffic in front of them. I hope you enjoyed this video by Aviation Abby, where we understood the functioning of the radar and its real-time implication in today's world. Stay tuned for part 2 of the video where we'll discuss about the types and uses of radars in the airports. If you like our work, do not forget to like, share and subscribe because your support is our motivation. This presentation was prepared by Shantanu and I'm Anvesha Pal presenting it to you. Thank you, signing off. Aviation Abby, go where you feel the most alive.